Hi everyone, this is Andres. This is my lab 7. The objective of this lab was to study curving motion and applying the momentum principle to it. So here we have the code in Python. I was given the mass of the star in WebAssign, and delta t was 1 day in seconds. Here I'm just pulling up the data from the Excel file and defined initial and final velocities using this input data. Initial momentum is just initial velocity times the mass, same for final. The delta v and delta p were also calculated. dp dt is simply delta p over delta t, and the momentum principle tells us that F net is equal to dp dt. When studying curving motion, it's best to split up dp dt into its parallel and perpendicular components, parallel being the direction, the same direction as momentum, and perpendicular being the perpendicular direction to momentum. dp dt parallel can be found by taking the change in magnitude of the momentum over delta t and multiplying that by the unit vector of momentum p hat. And according to the momentum principle again, F net parallel will equal dp dt parallel. And to find dp dt perp, since we know that the sum of dp dt perp and dp dt parallel equal dp dt, and from the momentum principle we can just find it by subtracting the parallel component from F net. And again we have the momentum principle, F net perp equals dp dt perp. This just updates the position and velocity from the data. Here I have arrows to visualize the forces going on. The black arrow shows F net perp, the blue arrow shows F net parallel, and the red arrow shows F net. I calculated the mass of the black hole using the formula for the force of gravitational attraction and manipulating it, solving for the mass of the black hole. It would just be the magnitude of F net multiplied the magnitude of the distance squared divided by g, defined here, the gravitational constant, times the mass of the star. And it prints out mass is and the mass. So I'm going to run it. And there it is. You see the arrows as well. For the what does it mean, how are F net and its parallel and perpendicular components related to dp dt and its parallel and perpendicular components? Well, Newton's second law tells us that they are numerically equal, so that's how we'd be able to relate them. But perhaps the interesting part is how they're different. Although numerically they are equal to each other, conceptually they are two very different things. F net is the sum of all the individual pushes and pulls due to the four fundamental forces we learned about, such as gravity, the electric force, and the nuclear forces. And these are basically just the total sum of these, and as well as the parallel and perpendicular component. And momentum, it arises from just observation of motion. Really, it's just as we know, gamma times mass times velocity, and dp dt is just that over the change in that over the change in time. So although they are numerically the same thing because of Newton's second law, they really come from two almost completely different places. For the what if question, if the black hole was replaced by a different black hole, the conditions are all the same except for the mass of the black hole, including the motion of the star was also the same. You would not be able to tell the difference when calculating the mass, because the force due to gravity is defined as a relation between the mass of the second object times gravitational constant and distance. So everything would be the same. Thus, when solving for the mass of the black hole, you would get the same result. Lastly, I want to show you that the mass I calculated, that I predicted, was indeed the correct mass shown here with the check mark on WebAssign. Thank you.